Hello and welcome everyone. Good afternoon or morning or evening, whatever it is for you, wherever you are. Welcome to our live stream today. My name is Michaela Woods and I'm a developer advocate at KX, and I'm going to be your host for today's session. Joining me is Connor McCarthy, who's going to talk to us at all things PyKX. So you want to say hi, Connor?
Yeah, hi everyone. I'm really delighted to be chatting with you today.
Cool. For those of you who don't know who Connor is, he's our VP of Data Science at KX, which includes, among many other things, being the lead architect for PyKX, which is our Python first interface for the Q programming language and the KDB Plus time series database. And since open sourcing PyKX, I think almost a year ago now, isn't it, Connor?
Yeah,
we've
had
yeah.
Oh, sorry, it'll be a year. It'll be a year on the 19th of May. So we're coming up on the anniversary of it being open sourced.
So exciting. So since then, I think we've had over 200,000 downloads on PyPy of the software, and it's continuing to increase. So we've got lots of people out there trying it themselves today, and we want more and more folks to try it out so they can tell us what it is they want from it, and we can continue to improve it. So we're really excited to have Connor on today to hear more from him about what it does. Just some housekeeping things I wanted to mention before we get started. Firstly, please submit any questions you have through the chat. We'll address as many as we can throughout the session to keep it as interactive and informative as possible. We have tried to invite a mixed audience here. Some of you folks might already have experience with PyKX. For some of you, it might be your first time hearing about it, and don't worry, the session is for all levels and levels of exposure. So if you wanted to comment in the chat, letting us know what your experience level is, that'll be really good for us to figure out who we're speaking with. And then secondly, this is being recorded and will be available on our YouTube channel afterwards, just in case you have to leave early or you want to share it with anyone who you think might enjoy it as well. So with that, let's go ahead and get into what everyone joined here today for. So I'm going to hand over to Connor now and let him talk about PyKX and tell us all about it.
Okay, great. Thanks for the excellent introduction, Michaela. So what is PyKX, I suppose, is the topic of the day, and how is it used? PyKX basically, as Michaela kind of alluded to, is a Python first integration or library for interactions with the world's fastest time series database, KDB Plus. Essentially, KDB Plus provides users with the ability to query pretty vast amounts of data, petabyte scales in milliseconds, and PyKX is the kind of view for that database from a Python user's perspective. So the way that kind of Michaela, I suppose, alluded to a little bit, the way that the demonstration is kind of structured is to really talk about kind of each of the personas or each of the people that PyKX services and surfaces its functionality to, and really to try and show you the breadth of what you can do with the library. Hopefully we'll have further live streams at a later date to talk about some of how the library can be used in very specific use cases, but this is really a general introduction. So the three things that kind of it touches upon are running time series analytics fast with familiar syntax. So think I'm interacting with my database like it is a Pandas-like API. I want to integrate with it using SQL because that's a query language that I'm familiar with. Or if I'm familiar with Q and the programming language that backs KDB or KDB interacts with most natively, I can have full access to that as well from a Python environment. Secondly, I want to create databases easily on day zero without any real expertise. So I want to be able to create a large database from Python data formats that I'm familiar with. Maybe they're PyArrow, maybe they're CSV files, maybe they're Parquet files, whatever. I want to be able to create those databases at large scales and maintain them using Pythonic syntax. And I want to be able to query large amounts of data in a short period of time, in milliseconds, once those databases are created. Finally, if I come from a different background and I already have existing KDB infrastructure, Q infrastructure, as many of our clients in finance and in IoT will have, I can integrate it within my existing infrastructure. So I can query that infrastructure quickly. I can embed Python into the processes that underpin that infrastructure and present to users Python functionality quickly. And ultimately, I can provide the power of Q to Python users where they work. So if I'm working on a trading desk, I can query data down from KDB plus infrastructures. I can run analytics, Python first, and derive insights without necessarily having to convert the data to a pandas data frame or a PyArrow object. Okay, so why, I guess, is it used? PyKX, as you kind of mentioned, Michaela, is released a year ago, open source, but prior to that, it was a closed source entity. It was available to clients under lock and key, ultimately. But as we started to see that more and more clients were getting more and more value, we wanted to make it more freely available. So there's a free trial version of it that people can get started with today, which I'll go through the sign up process for and walk through how it's kind of made available to users. But ultimately, the kind of three pillars that are aligned here are really what PyKX is meant to do for our users. It's meant to accelerate the work that they do. It's meant to democratize access to the data that they have available to them today or that they're going to create for their user base. And it's meant to modernize the infrastructures that exist for the users that already have KDB and Q. So on the acceleration front, what we're really talking about is users being able to replace existing analytic workflows with versions that just run faster. So Citadel had a presentation at our event KXCon at last year, where they presented some of their complex event processing workflows. Essentially, what they're doing is using PyKX as a replacement for Pandas and NumPy style workflows for creating analytics that run on streaming data. So previously, the analytics for, I think it's volume surface calculations that they had on their side within the quant workflows were taking minutes to run. Now that they're using PyKX to do the calculations and the upserts on the data that's being produced, it's taking milliseconds and running much more efficiently in doing so. Additional to that, we have a large pharmaceutical company that are using it for replacing Spark for really large scale operations. So large scale outer joins that are running about 10 times faster than the previous version and allowing them to offboard some of the workflow that they'd been doing with libraries that maybe weren't as efficient that they had themselves. On the democratization front, historically, KDB has been seen as something that's difficult to interact with. It's kind of for elite developers. PyKX is really intended to reduce that perception and ultimately is doing so. So in one of the tier one investment banks that we work with, they now have PyKX being used by hundreds of developers who can run analytics locally using Python only, querying their databases. And additionally, they can run efficient analytics on KDB data and databases wherever a Python process will run. So if you're in Azure and you have access to Jupyter Notebooks and a Python environment, or you're running in a Databricks environment and you can get access to PyKX, provided you have a license that will run in those areas, you can run PyKX there. So you can query your databases from wherever Python will run ultimately.
I think
sorry, Michaela, go ahead.
Yeah, no, I think that's really exciting. Just from my experience, what I've seen at different banks is there's a lot of, usually people or quants or traders that are enabled on Python, but not KDB or not Q. So really giving people an entry point to be able to take advantage of what's there already for them is really, really good. And do you find those users are then just using PyKX or they might want to then have a look at the Q language?
Yeah, fundamentally, the way that it's kind of operated is that we've had users that come in as a starting point and maybe they don't leave the Python first ecosystem or set of functionality. But a lot of them will. They'll eventually want to learn some more Q so that they can get access to maybe more advanced analytics that aren't presented immediately to them, or they need to write an analytic that is going to be significantly more advanced that maybe Python syntax won't be able to do efficiently. So they'll write it in Q. But the intention really is to allow both kind of operations or personas to run in tandem as seamlessly as possible, ultimately.
Awesome.
I suppose then on the last pillar, modernization, really what we're trying to do on that front is to improve the performance and the consistency of how users use Q and Python together. A lot of the listeners or viewers that aren't too familiar with Q and KDB maybe might ask why that's needed, but historically KX and the community as a whole had produced a number of Python interfaces which did very different things. So it was embed Py, PyQ, and QPython, which surfaced different functionality for different users and different use cases, but ultimately made it very difficult to maintain dependencies between things. So PyKX basically allows users to replace all three of these with enhanced flexibility and performance, and the aim is that performance improvement and the flexibility will continue to increase over time as the library is developed and users basically provide us feedback. And then the last piece really on the modernization front is how we use it internally. So how PyKX is surfaced in the rest of our product suite. So we have a dashboarding tool, KX Dashboards, which now has a Python front end for it, which can be, which uses PyKX under the hood. Our Insights Enterprise functionality uses PyKX for some of its stream processing work on the Python front, and then KDB.ai, the subject of a number of our live streams to this point, uses PyKX for a lot of its data manipulation and ultimately producing the data in the database that's being persisted. So it's used in a lot of places, a lot of different ways, and it's very flexible and powerful. But yeah, it's really aligned with those three pillars is the way that we kind of develop the work that we do. Okay, so I suppose that's the pillars. What does it really provide though? So there's kind of 6 different things that we kind of can discuss as kind of broad topics and functionality. The first one really is around kind of talking to the personas that consume it. I've talked a lot about like there's Q developers, there are Python developers, there's people that are going to interact with this in lots of different ways. Many of them will come from a Python background previously, or at least will have access to it. And the intention with PyKX is really to allow users to upskill at their own pace. So Michaela, you mentioned that sometimes we might want a user to get more in depth into Q programming language for building advanced analytics. But for lots of people, they won't get past the point of, I need to query data, I need to convert it to pandas efficiently. But when they do want to dip their toes or look at a demonstration we produce, we're going to provide you the way of doing that quickly and easily. We've really tied integrations with Python at kind of a fundamental level. So your extensions to NumPy in order to allow data to be converted particularly efficiently and getting more efficient as kind of the weeks and months go on, as well as to leverage some of how Python deals with data at kind of a very fundamental level so that we can run things fast and users don't have to worry about the latency of data conversions, for example. Running time series analytics fast is obviously a big point in this. KDB historically has been really, really amazing at doing that. Our benchmarks on kind of Stack are best in class, but Q and KDB has always had kind of extremely efficient window joins, as of joins, things that are used to do analysis across kind of bitemporal data, so data which contains two timestamp values. When we talk about interoperability, conversions can be as flexible as you want. So when I'm talking about interoperability in this regard, I'm really talking about I have data that I've queried from a KDB process or from PyKX generation itself, but the function I need to run to fit my machine learning model is dependent on data being in the form of PyArrow or Pandas. PyKX basically provides the ability for you to go from our format to Python, NumPy, Pandas, and PyArrow, and then the reverse. So you can kind of bidirectionally switch between the two of them efficiently in order to get access to data in a form that you need for the analytic that you want to run at any one time. We'll also be releasing, hopefully next week, the next couple of weeks anyway, integration with Streamlit. So Streamlit's a fairly common visualization tool for creating kind of Python first dashboards. Essentially, they're data science widgets PyKX, we're adding a new type that Streamlit can deal with, which allows them to query historical KDB infrastructures or query Python ecosystems to produce visualizations pretty nicely. Inter-process communication then is probably the next one. If you have an existing ecosystem, a location where you need to create a server to access your data, you maybe need to produce a gateway, or you need to restrict access to a user to be able to query data. It's a very common access pattern for data generally. PyKX's inter-process communication is pretty quick. We use Q, the programming language's serialization methods to retrieve the data faster. So if anybody is dealing with QPython today that's on the stream, PyKX is nominally about 8 times faster. We've had it independently benchmarked by a number of our clients, and about 8 to 10 times is the kind of performance improvements they've been seeing generally when it comes to querying. And then the last piece I kind of talked to a little bit before, it's run wherever Python runs. So Q itself as a programming language can run on Linux systems, it can run on Windows systems, it can run in Mac, but you might not have a kernel, or we might not have gotten to the point where we have an embedded solution for a cloud environment that you need, or a cloud environment that you want to be running in that's running specific hardware. PyKX basically means that you can take your Q, KDB analytics, and run them in an environment that you want. Or if you don't want to do that, use PyKX and its kind of Python first mode of operation, which is the one that we will be showing today, to create analytics or run functionality really quickly to get access to the kind of high-speed time series analytics that we're kind of discussing here. Okay, and with that, demo time. So I'm going to run a demonstration here, which is largely kind of a full end-to-end. It's meant to be specifically kind of tailored towards a new user, somebody that's coming in that is kind of Python first, that maybe hasn't had any access or use of KDB in the past. And what I'm going to do is go through not necessarily the pip installation part of it, but the setup of a new license that the user gets access to, how you can create PyKX tables, how you can create kind of KDB style format data, how you can run some analytics, do some data joins, run some functions, how to create a database, and how to query that database, and ultimately how to maintain it. And then at the very end, I'll show how, if you're a Q first user, you can interact with Q in a way that feels familiar, but from a kind of a Python ecosystem perspective. Okay, so to my Jupyter notebook. This notebook I am intending to put up onto the KX GitHub in the next couple of weeks. Basically as an introduction, it'll be fully self-contained, but the aim being that a user can run the entire thing themselves and can get access to value out of it. We'll put up some links a little bit later on to the KX Academy, where users can test out PyKX itself and run through some of the training courses and functionality that Michaela and her team have been producing over the last number of years. But this will be basically a super quick introduction to some of that. I won't get into any advanced methods or functionality, but if anybody has any questions specific about that or anything that you want to see the next time that I'm presenting on this, let me know.
We just had a question there about getting a link to the GitHub. We will make that available just in after the session, and we'll add the link. It's just not up there right now.
Yep, that's absolutely correct. I'll also have a QR code that you can scan at the very end to get access to the GitHub too. Okay, so as with any demonstration in Python, I need multiple different things in order to run it. Initially, import some libraries that I'm going to use within the presentation. Standard enough stuff, nothing like majorly complicated. I'm going to get access to the current directory that I'm in right now. Basically, that's going to be used so I can link to specific data. I can create databases where I expect to create them. It's not really for any reason other than that. So this demonstration, I've removed my existing license, my commercial license that I have access to, and essentially operate the same way that anybody would get access to PyKX when they pip install from PyPy or conda install from Anaconda. So all things going well, when I import PyKX as KX, I'll be provided with essentially a walkthrough of, do I want to get a license? There are modes of PyKX use which allow you to query functionality in the same way that QPython did without needing access to a commercial license or a personal license. But for the purpose of this isn't going to be the part of the conversation here. So I've been unable to locate a license for PyKX. I can run on license mode, but reduce functionality. Would I like to continue with installation? The answer is yes, because my demonstration would be difficult without it. What's my intended use of the software? So this is the 2.5 version. In my case, I'm using a commercial license. There is a commercial trial and there's a personal trial. This basically just will modify how the steps for getting started change from this point on. So in my instance, I'm running a commercial trial, at which point it'll ask me, do I want to apply for a license, which I need to do. So if I wanted to be redirected to the license installation screen or the screen that gets me access to get an email to say I want a license, I can hit yes on this. In my case, I have the license installed already or available already, so I won't be doing that for this. Okay, so select the method that you want to activate your license key. There's basically two things that you can do. The email that you'd receive when you get access to your personal license or your commercial license will have a base64 encoded string, basically a license key that's available to you that you can copy and paste into a terminal here, or you can download the file that also gets sent to you. So in my case, I have the file, and I'll have to be very careful here. Licenses. Let me just quickly double check that I have it spelled correctly for my thing, because it will be more annoying if not. So I've passed in the location of my license. When I hit enter, it'll say that my license has been installed successfully. This is actually a development version. The restart Python for this to take effect doesn't actually matter. That'll be removed before 2.5 is released. Okay, so PyKX is, sorry, go ahead.
Just before we pop on, that's great to see, Connor, and see how quickly you're able to get everything you need to have PyKX locally. We have just one question from Andre. Does PyKX cover use case Q-kernel for Jupyter? So I think he's talking about the Jupyter notebook and the kernel you're using there.
So currently Jupyter Q, which is the predecessor to, which uses embed Py, doesn't support PyKX specifically. At the very end of the presentation, I'll show how in a Python kernel, a user can get a Q first experience, but currently it's not supported. It is on our roadmap for us to update Jupyter Q so that it will support that as well. But additionally, for us to provide more Q first interactions or experiences for Python kernels more generally. The reason for doing that ultimately is, like I said earlier, there are a lot more locations where Python kernels will be able to be run. So we want to provide as native a Q experience as possible in as flexible an environment as possible. And that will be Jupyter Q in some cases, but it'll also be Python environments for other users.
Cool. Thanks, Connor.
Cool. So for the demonstration, so that this is fully self-contained, I am not using a queue process as my server in the IPC cases. I've generated a server, or will generate a server that's a Python server. There's two reasons to say that. The first is that it's right, to be honest, and let people know what you're actually doing. But secondly, it's a lot more temperamental than a queue process would be when I'm doing IPC stuff. So I may have to restart process, but in order for the notebook to be self-contained when we release it, I've put this script in, which is basically just creating a server. Okay, so we'll come back to the server part of it in a little bit, but how are PyKX objects created? Essentially, what I mean by a PyKX object is the same as you would if you were talking about a NumPy array or a pandas data frame. It's basically just our representation of data. and it happens to be called a PyKX object, but under the hood, it's the exact same as if you were in a queue session. Those objects that you produce are PyKX objects from our point of view, at least for presentation point of view. So users can create those objects directly with Python data. So in this instance here, for anybody that's familiar with Pandas data frames, this is a very similar syntax to how Pandas creates its data frame objects. So kx.table replace for pd.dataframe if you're in a Pandas syntax. We pass in the columns that we want, dates, create random data using PyKX itself to create random date values, create random what will become symbol values, but strings, create random integers, and create random floats. And then I'll call .head on it to get access to the first 10 columns or 10 rows, apologies. So when I run that, we basically have done a couple of things. We created random data from the initial Python data that was produced, that was presented to us. We converted that to Q, and then we created the Pandas data frame from it. So you've basically been able to take Python representation of data and create a PyKX object ultimately.
Maybe we'll just zoom in once more, Karen, just to,
yeah, of course.
It's a bit harder to see with the table. Yeah, that's perfect.
So that's useful enough. It allows us to quickly get to a point where we have an object that we can start prototyping with. But not all data is Q data or PyKX data. If it was, my job would be a lot simpler, but that's not really the case. So the way that we allow users to be more flexible in how they create PyKX objects is to use kx.to-q. So convert a thing to Q. In this case here, we are going to convert 3 different object types. So we'll convert a Pandas data frame initially, which will produce a PyKX table under the hood. We can convert a NumPy array here, doing very similar things, or we can convert a Python list. It'll also work for PyArrow arrays or PyArrow data frames or tables as well. This is done explicitly anytime or implicitly anytime that data is passed into a function, for example, that uses PyKX. So if you pass a data frame into a function that's a PyKX function, it'll basically do the conversion for you and then run your analytic against the KDB tables, which is really useful for kind of flexible solutions to things. So we had a server that I started a minute ago, and I warned everybody that it might be a bit temperamental, so I might need to run things multiple times. This is where I figure out whether or not that was true. So what we're doing in this instance basically is mimicking a client-server interaction, which would be the case in most kind of financial institutions or with many clients that maybe want to protect some of their data or allow only certain interactions against it. So in this instance here, we're running kx.sync queue connection. We're creating a synchronous connection against port 5010. Setting no context equal true doesn't really matter for this. It's a performance thing. It reduces some of the overhead for the objects that we're creating. And then we're going to run a SQL query. So in this instance here, my table or my process has a table called tab. So I'm selecting all of the data from table where column X is equal to A and where X1 is less than a specified value. So when I run this here, as I said, probably didn't work the first time, but the second time, it did give me access to the subset of data that I requested from the table.
So using PyKX, we're able to run SQL directly on an external process. That's really, really cool.
Yeah, so in this instance here, the external process has access to one of our Cloud Edition libraries, s.k, that's available for users that download the PyKX licensed version, the version that comes with the license walkthrough. And s.k basically has given me access to be able to run the SQL commands on the server, which will work against the HDB if the table in this instance was a HDB. Historical database for anybody that doesn't know that syntax. But additional to all of that, we can kind of run Q functionality directly. So if I create a function here, kx.q is the way that we tell execution of PyKX that I want to run Q code and I want you to produce a PyKX object. So when I run min-max scalar here, I'll actually show you what that looks like. Max scalar. It's a PyKX lambda function. It's a purely a Q function under the hood. And when I am getting access to it, I can also start running functions themselves. So here, I'm going to run that min-max scalar function against a vector of Q objects. So in Q, the function till creates values from 0 until the specified value that you've written. So this will be from 0 until 999, basically, in this instance. So when I run this, you'll see that I create a PyKX object, which is a float vector. It's a vector of floats that's after running Q code against the Q object that was produced. So there's multiple different ways that you can generate data, get access to PyKX data. Some of them are more complex than others. Obviously, in the case where you're creating the PyKX objects directly, syntax is very familiar. If you have to run a query, you can run that query with SQL if you have access to the SQL functionality. Or if you want to use some of the Q or PyKX primitive functions like till, you can create objects that way otherwise. Okay. So how do I interact with that data? So I've created data or I've gotten access to data. I'm in a good place where I have access to the functionality that I want. But what can I do with it once I have it? There's lots of things. Ultimately, we have a pandas-like API, which I'll run through a bit here. I'm only scratching the surface on the stuff that's available in it. But ultimately, what we are able to do in this instance is I'm going to load in some New York City weather data. It's a CSV file from Kaggle, which basically is taking Q's functionality for automated CSV reading, wrapping it a little bit on a PyKX style function, and allowing users to load the CSV file. So when I get the head of the data in this instance, you can see what that data looks like. So here is a HTML representation of the table that I've loaded. You'll notice here some things like E or H, which might be unfamiliar to some people. Ultimately, they're post function or post value arguments to say what type the data is. So E is a real value, smaller than a float. H is a short value, it's smaller than an integer, basically. So small representations of the data. One thing that you'll notice, which I'm going to change as we kind of walk through some of the pre-processing, post-processing steps, is some of the column names are a little bit annoying if you were to try and deal with them in query, for example. So here, degrees Celsius is not a nice thing to have to query against. There's also spaces in some of the column names that are there. So we'll want to also kind of clean up a little bit of that. And the way that I'm going to do that is, in theory, very Python first, very Pythonic. So how we do that in PyKX now is basically the same as how Pandas deals with it. It's not exactly the same. We've written the methods ourselves so that they're as efficient as possible. And so we're not deferring to Pandas specifically. We're trying to be as efficient as we can be using Q first under the hood. So here we rename all of the columns that had spaces with values that are going to be easier to query against. So change degree Celsius to temperature underscore Celsius. And I can get the head of the table again in order to show that the presentation is slightly different. For those that are clearly seeing that I'm skipping over some, it's for a reason, because this is an interactive demonstration. Ultimately, I'm going to remove the columns that aren't going to be used in the end state of what I'm trying to do here. So here, I'm going to drop columns that I don't need. I don't want to know about cloud cover. I don't really need to know about wind direction for the analysis that comes after a lot of this. So I'll remove that and I'll get the head of the data again, which shows that the table is now pretty tight in terms of what it has columns wise. All right, so that's great. I want to query that data now. How do I do that? I can do that Pythonically using Boolean lists ultimately. So in the same way that you would for Pandas data frame, you can query using this syntax. So anywhere where weather data for temperature Celsius is less than 2, or where it's rained, get me the weather data information back out. So once that's done, we see very bad days in New York, most of them during January, February, and later months in the year. Although it's not selective, I think, in New York from time to time. Okay, so it's fine. We've been able to query our data. We've been able to get smaller versions of it. We haven't had to really touch Q just yet. I also want to extract the data information from my times so that I can run some calculations against it. So in the time column up here, you'll note that it's nanosecond precision timestamp in this instance. When I run weather data, get the time information and run .date against it. When I rerun the table functionality here again, you'll see that I'm after creating a new column called date, which will be used in the following calculation. So that's grand, sort of pre-processing on data, producing some functionality. I can run some analytics now. So in this instance, pretty basic, but group the data by date and then calculate the mean value for all numeric columns. So basically all of the following columns except date and time in this instance. So when I run that, it'll take a second to run through the calculation itself, but it should produce a key table to us, essentially the same as an index table in Python or Pandas specifically, which produces a representation of the data that would align with what I want. In a practical application in finance, for example, that might be you're grouping by symbol and something else and trying to calculate position values within it, or trying to calculate mean values within it. So the application here is specific to weather data, but the intention is that it's obviously flexible to whatever your use case is. For the purpose of the demonstration, I'm now going to drop that column. I don't want it initially. I will reintroduce a date column later on, but for the purposes of this, it's being removed. So those are operations on table objects, mostly Pandas-like, Pythonic in nature. What if we want to operate on vector objects? So we've supported or added support for some primitive functions, but there's also the ability for users to apply functions against vectors. So it'll take the full vector as its first argument, and then you can run whatever calculation you want on it after the fact on that. So in this case here, temperatures, apply the function lambda. It takes 2 arguments, x and y. Run a moving average for a length of 3 and return the result to me. So that'll basically give you a rolling average of temperatures over the specified time. In this case, it could have been dates for a subset calculation if we had done it that way. Okay, so that's all in memory stuff. That's all reasonably kind of tight, concise. Data isn't huge. It could be millions of rows of data, but you're not talking about kind of petabyte scale historical databases or anything along those lines. And for users that are coming to KDB for the first time and don't have any access to Q originally, they may not have a database, and it may be difficult for them to create one today. So PyKX has basically added functionality for database creation. The intention with this really is to make it easy for users to get started really quickly. If you need to move to a real production version of a database, or you need to have redundancy on it and scalability and everything else, we have enterprise solutions which are intended to help move users towards that. But for a person that wants to POC something or wants to get started really quickly, this functionality gives them that flexibility. So how does it work? Basically, what I'm going to do is I have a database location that I'm going to be saving my DB to, which is temporary/DB, very cleverly named. And I'm going to call it New York City Taxi in this case, because it's New York City Taxi data for a number of years, a number of months of a year. So that's stored in data taxi. what does it contain? It contains basically 3 months worth of New York City taxi fare data. For the purposes of the demo, just so it runs quicker, and so that people, when they're running the demo themselves, don't have to download gigabytes of data. I've basically removed millions of rows from here. It's going to be against about 5 million odd rows across the 3 months. But you can scale that up way beyond that. The data is available open source. You can add it in yourself, but downloading tens of gigabytes of data is not something that's particularly easy to do yourself from a GitHub. Okay, so what does a single day of that data look like for introspection purposes, but also so you can see kind of how we're going to modify it over the course of the next couple of minutes. Basically, the single day of data contains, I think, 18 columns across multiple different things. So it contains surcharge information, how much a person has paid, what their fare amount was, indications about the location that they were in, information about kind of what payment method they had. And we're going to modify that a little bit as we kind of work through the rest of this. So in order to create the database, we need to create a database object. Here, kx.db with the path to the location that the database is going to be stored in. So once the DB entity is instantiated, it's basically a singleton object. So you get one of them. It's one of them per session, but it allows you to create a database and add tables to it and add partitions to the data so that you can create really large databases ultimately. Okay, so in order to create that database, we're going to read in the CSV files and we're going to pre-process them before they're persisted. The way that that's done is that I'm going to loop over the folder locations, or the folder location that contains the data and the named CSV files. I'm going to get out the month information associated with the month that the CSV was associated with, so I can create a split database across months. I'm going to read that CSV. I'm going to rename the columns because passengers is better than passenger count, and trip distance is better than trip distance. I'm going to convert some of the data types a little bit. I'm going to create that mapping that I kind of talked about earlier on. So here, from 0 to 6 have associated values. One is a credit card, 2 is cash, 3 is no charge. I'm going to create a new column called payment type that's associated with that information. I'll remove any columns I don't want, filter out any data that isn't needed within the demonstration. So specifically, remove data for pickup times that are outside of the day or month that I want, because pickup time is not the end of the trip. It's obviously the end of the trip is the time that's used to store where everything is bucketed. And then finally, to the time series stuff, I'm going to sort the values on pickup time. So I get ascending data. I'm going to rename the weather data to be pickup time instead of time. And then I'll run a as of join. So I'll find all occasions within the taxi data where there was an associated weather data value. So basically trying to get a mapping of what the weather was at the time that a user was getting into, or a person was getting into a taxi. And then run db create. So for the join data, for the table name that I've defined, and for the month that it's associated with, start creating a database. So I've written a database partition to table 1 New York City taxi, and then run 2 additional ones on that. The warning here is arbitrary. It's not needed in this instance. Again, it's a dev build that I'm using today. Okay, I said it.
Sorry, just want to say how awesome this is. I think this, for people coming from a non-KDB background, maybe used to using pandas, I think this is like one of the ways where PyKX is really different. It's not just a library for doing data analysis. You're actually doing like a database creation here as well to get the most out of the the analysis tool and the language. So yeah, I think it's really powerful to see that.
Yeah. And to show how it's kind of stored once the database is created, you can kind of look at it like this. So basically running tree against a directory will tell you what your folders and what your values look like underneath that. So here we're creating folders for each individual day and for the table that's in the database and its associated values. So when we go to query it, we can be very quick and selective about how we get access to data. We don't have to look at all of the data and filter it all down. We look at specific columns that we need to get access to and get access to them quickly, essentially. So when I want to present that, DB New York City Taxi is the way that I do that. For anybody that is very familiar with KDB, I'm not pulling everything into memory here. It's a representation of the data, and that's a partitioned table, basically, which is just a table that's stored in the format that I showed above. So last kind of couple of things then, before I kind of go back to the slides. If I've created a database, how do I make modifications to it, or how do I add information to that database? It's not a particularly straightforward thing in a lot of cases, but we've provided helpers that allow you to get a lot of the way there if you need to. So we've provided DB copy column in order for you to take from the New York City taxi data, pick up time, and add a copy of that. We can apply a function to that data here and write down the results so that we get additional table information here, producing the date column that I had removed from the weather data for this purpose, and then rename the column itself. So time copy is now called date, and when I present the table this time out at the end, you should see that I have a date column now. Okay, so the last kind of section really within the demonstration is to kind of talk about querying databases. One of the most familiar kind of patterns that most people have when they talk about querying databases is essentially this synchronous connection pattern that I was showing earlier on. So you're creating a connection to a database that exists separately, you're running a query against it, and you will get access to the data at that point. You're not really talking about accessing the data as it stands within a process specifically. It's always pretty much remote, and there's lots of reasons for that. But with PyKX, you can basically load in your database directly and query it immediately. I'll show why there's benefits of doing that now, but basically, in this instance here, we have a connection that's being created against that port 5010 that I produced before, and I'm going to tell it to load a database. So it's going to load the database we just created. It's then going to run a SQL command against it to select star from New York City, where month equals 2019-11, one of the months in the database. So when I run that query, it ran fine. We'll show that the results are appropriate in a second. And I can run a local version of it as well, which looked like it ran a little bit faster, but we'll prove that in a second. And here we can show that all the data is equivalent between the two queries that were run and what the local data looked like. So it's the head of the local data basically gives us the query data out. Okay, so why is that beneficial? The benefit really comes from the time, and the time itself is not actually the analytic running specifically. More specifically, it's the time to transfer the data from one process to another is what's taking the time. So this second time it will look like it runs for longer, but it's running more loops because it can. So we'll go from about 325 milliseconds to 30 odd milliseconds probably for the calculation to have run, hopefully by the time I finish this sentence. So having access to the data locally and mounted makes it available to me with much more with a significant reduction in presentation latency, which is obviously super valuable if you need to run analysis across a large amount of data. The last two things that I'll run before going back to the slides is really around querying using Q. So we talked a lot about PyKX and Python first usage. If you have access to Q, or you know Q itself, or you need to write analytics that are more complex than something that we've produced today and that you would like to see more of, you can get access to Q directly. So in the first case, running the equivalent of the month query calculation that was done in SQL, And in the second case, running something a little bit more complicated, getting the total number of passengers, the average temperature for every or by date from the data sets anywhere where a user was using a credit card. Finally, there's a QSQL style method for that, which is basically a slightly more Pythonic version of doing the query. That's being extended right now. By the time it gets to later this year, that should look a lot more akin to polars in how we provide that query syntax. And then the last thing that I'll cover, I'll skip over the I want to use Q itself piece at the very end, so we can get back to the slides to talk through the last pieces. But all right, I've finished doing my analysis in PyKX. How do I get my data back to Pandas or PyArrow because I need to run a machine learning model or something that one of my quants has produced to analyze the data? PyKX basically provides a couple of methods to do that. So there's a .pd method to convert here the single day of New York City taxi data to a Pandas data frame. You can produce a PyArrow table doing it this way with .pa. If you take out a single column, you can convert it to a NumPy vector using NP, or you can take a slice of it in this instance and convert it to a Python list in this case. So flexible, allowing you to kind of interact between the two of them, get data from Python representations, return it to Python representations or more traditional Python representations of the data, and then get access to the analytics when you need them using PyKX for the larger scale things. Okay, and the last slide really to show before a bit of a call to action is kind of the journey that we've been on. So I've talked a lot about like what it is that you can do and how it is that you can work and what PyKX is intended to provide. But really the story is kind of only getting started on our side. We wrote the first lines of code in 2019, and then for 2 years basically didn't do very much with it. We POC'd the library back in 2019, but in 2021 we were provided by our core team, the team that provides the language Q that powers a lot of this, a version that we could embed of Q into Python processes, which is how this nominally operates. And through then, it's kind of been basically a slideshow of what do clients and users want, how can we provide it easier and faster, getting us to the point that as of May of this year, we have 200,000 downloads on PyPy, which is obviously great for us. It's a thing that we're super proud of, but we're continuing to increase functionality. So this will be recorded. You can read through this. I'll be updating our roadmap on our GitHub documentation, or our documentation in the next couple of days that kind of aligns specifically to this. But it's really only the start. And what I would encourage anybody that's on the kind of call today or is watching back on YouTube at a later date to do is just reach out, open an issue on the GitHub, email us, message us in the community forums. We love to hear what people want to see more of and what they like about the library, and ultimately what they're getting value out of, because we want to produce more of it ultimately. And as mentioned, here are some of the links. I'll leave this on for a minute and I'll talk through them as we kind of go. Again, the recording will be there, so you'll be able to see some of this. So on the left-hand side, there's our documentation. It's a link to code.kx.com and to PyKX. It has all of the getting started installation guide parts of it, as well as our API documentation, examples, and so on. Link to our GitHub, as Justin had requested, which basically shows you what the code looks like. You can open contributions against us. It's an introduction to how users can contribute to PyKX, which we can, I'm sure, include in the links that are added to the YouTube video, ultimately, which we would love to see people showing that. There's an academy where you can get certified to say that you have used PyKX, you know what PyKX is about, that Michaela and her team produce, which we help to curate, which will allow you to kind of get up to speed with Python development with KDB+. And then the last one is one that we added today, which is a user experience study that we're wanting to do. So if anybody is keen to try the library, maybe hasn't done so before and wants to help it evolve, or if you've used the library before and want to help provide us feedback on things that you want to see more of, we're going to be running a usability study on the library itself to see areas where we need to focus more on and areas where our documentation or GitHub and so on don't provide enough information to you ultimately as the end consumer of the product. Okay, and that's it.
Wow, thanks so much, Connor. That's been really, really great. I think that's a good place to wrap up, I think. Thank you again to Connor for sharing everything and all of his valuable insights into getting started with PyKX. Hopefully everyone found it very useful and will go and download PyKX and try it out and let us know what you think. Just to mention, we do have a number of events coming up, both in person and online. Our next one is our meetup in person in London on Wednesday, the 22nd of May. And part of that actually is a panel I'll be hosting with Connor, so you can see more of us and some other key experts that will be there. So not just talk about PyKX, but also about KDB Plus more broadly. So do register and come along if you're in town. We'd love to meet you in person. And I'll also be hosting regular LinkedIn live sessions, just like this one, talking to other users and experts. So if you have any suggestions for what else you'd like to see on these, please let me know. You can just message me on LinkedIn or chat below. But yeah, that's it for us until next time. And thanks again, Connor, and thanks to everyone who's tuned in. Okay, that's it, guys. Take care.